The title of this note is Gaussian Elimination. And our goal is to be able to use Gaussian elimination to solve a system of equations that has 3 or more variables. So what is Gaussian elimination? It's a technique that we're going to use to solve a system of equations. And we can use it for any system. It's especially useful when there's more than 2 variables. So last year in Algebra 2, you learned about the elimination method. You probably practiced the substitution method, even graphing. And those were great when we had 2 variables. But once we had 3 variables, solving by substitution or elimination started to get a little tricky. So we have our Gaussian elimination, which is a method that will make it pretty easy to solve for a matrix that has 3 or more variables. But we're going to start with a matrix that just has 2 variables, just as an example. So the matrix we're going to look at is 2x plus y equals 8 and x plus 3y equals 6. We're going to turn these into matrices. So first, we're going to have a matrix of all the coefficients. Those are all the numbers that the variables are being multiplied by. So I have 2x plus 1y and 1x plus 3y. Those are the coefficients. They are being multiplied by the variables x and y, and it equals the constants 8, 6. They're called constants because they're numbers without variables. So a little vocab that we need to be aware of here. We have our coefficient matrix, and our constant matrix. This is going to be a lot easier to solve if we use something that's called an augmented matrix. An augmented matrix is one matrix that's stretched out. That's what the word augmented means. So the augmented matrix is going to look like 2, 1, 1, 3. And then we're going to have a vertical line through the middle of our matrix, and then 8, 6. In the augmented matrix, this vertical line that we drew in, it really just represents our equal sign. So we're taking these 3 matrices here, and we're simplifying it into one augmented matrix. And with this augmented matrix, we're going to use a technique called Gaussian elimination to basically eliminate all these extra numbers, and an answer is going to fall out of this matrix. So the goal in Gaussian elimination is to get the matrix into what is called row echelon form. And you might also see this abbreviated REF, row echelon form. So row echelon form says, okay, I have this matrix, well, this augmented matrix, and I want the number 1 to be along the main diagonal. Everything below the 1 is going to be the number 0. And there can be any number in the other position. So I'm going to use an asterisk to represent any number. So this is called row echelon form. So we have our 1s on the main diagonal. We have a 0 below the main diagonal. That's a 0, so you can tell the difference between a 0 and an O. So we have a 0 below the diagonal. And everywhere else, we can have any number. It could be 1, 0, positive, negative, any number at all. Fractions, decimals, pi, any number at all. Any number is allowed above the diagonal. That's what it would look like as a 2 by 2. If we had a 3 by 3, same concept, we would have 3 1s. 0s below the main diagonal, anything above. And so on and so on. We could have a 4 by 4, 5 by 5, as many as we wanted. So our goal is to take the matrix that we had, and we're going to make some changes to it, and we're going to make it look like this row echelon form with mostly 1s and 0s. So how are we going to do that? We're going to do that using row operations. There are 3 row operations that you're allowed to do. The first move you're allowed to make is you're allowed to switch rows. And we're going to jot down what we're doing. So if you're going to switch rows, let's say I want to switch row 1 and row 2, you're going to use that double arrow symbol to show the reader that you switched row 1 and row 2. The other move that you're allowed to make is you're allowed to multiply a row by a number. Think of that as distributing. Everything in that row is going to get multiplied by a number. It has to be a non-zero number. You can't cheat and multiply through by 0. So let's say you want to multiply everything through by 4. All right, so this means I took row 1 and I multiplied everything in row 1 by the number 4. The last move that you're allowed to make is you're allowed to add 2 rows. So if you want to add row 1 and row 2, and then you have to put your answer into a row. So you can put your answer in row 2. So these are the 3 moves that you're allowed to make. Remember, your goal is to take that matrix that we first started with, and we're going to try to get it into row echelon form with those mostly 1s and 0s. So what are the steps for Gaussian elimination? The first step is we're going to write it as an augmented matrix. Then we're going to use our row operations and to get it into row echelon form. That's those 1s with the 0s below any number in the other position. Once we're in row echelon form, we're going to write the matrix as a system of linear equations, but the last equation will already be solved for us. And that's important because then what we'll be able to do is we'll be able to use what's called back substitution to find the solution to the entire system. And we're going to walk through an example of this. But before we go through our example, I do have a couple of hints to help you as you're doing your Gaussian elimination. First hint I have for you is to work what's called down the staircase. So if you're thinking about, here's the matrix that you're working with. Remember, you want to get it in row echelon form. Down the staircase means that you want to start by working on this 1 here. And then you're going to go down and work on the 0, and then you're going to go over and work on this 1. And if you had another row, you would go down and then over again and then over again. So you're going to go down the staircase. If you're trying to get a 1 in the first position and you're stuck on what to do, try multiplying. That'll usually help you get a 1. If you're trying to get the leading 0, usually adding is a technique that'll work. So let's go into our textbook, onto page 805, and we're going to do example 5. So we're going to go through all the steps here. So example 5, we have 2x plus y equals -8, and x plus 3y equals 6. So remember, step 1 is to write this as an augmented matrix. So we have our coefficients, and then our line to represent the equal sign, and our constants. So that's step 1. We have an augmented matrix. Step 2 is we're going to get this into row echelon form. So we're going to work down the staircase. We're going to work with the top of the staircase. And remember, our goal, I'm going to write it off to the side, is 1, 0, 1, anything, anything, anything. So that spot that I've highlighted in blue, that 2, we want it to be a 1. You want to do this as simply as possible. Well, I already actually have a leading 1. So I'm just going to switch those rows. I'm going to jot off to the side what I'm doing. I'm going to switch row 1 and row 2. And so now row 1 is 1, 3, 6. Okay, you're switching everything. That's moving to the top row. And the bottom row is now 2, 1, -8. And I did that so that I would have a 1 at the very top corner of that matrix. Okay, so I'm going to work down the staircase. I've got my 1. So now I'm going to move down, and I'm going to work on this number 2. I need that to be a 0, thinking back to my goal here. I need that to be a 0. So I'm going to ask myself, okay, what can I add to 2 to get 0? And I know that 2 plus -2 equals 0. So So I want to add a -2. And I'm going to look at the first row. It's a +1. To make it be a -2, I'm going to multiply it by -2. If I take -2 times row 1, that'll give me a -2 here, plus row 2. So -2 plus 2, that'll give me my 0 that I'm looking for. And I'm going to take this and I'm going to put the answer into row 2. Remember, my goal was to get that 2 in green to become 0. So I needed to add to it -2. And the way I'm going to get -2 is I'm going to multiply the other row by -2. So now we have, the first row does not change. Okay, now I'm going to follow these steps for every single column. So I have -2 times 1 is -2, plus 2 is 0. Remember, I'm putting my answer in row 2. Now I'm going to work on the next column. So I have -2 times 3, that's -6, plus 1, that's -5. Now I'm going to do the last column. -2 times 6, that's -12, plus -8, that's -20. Okay, so I'm getting there. I've got my 1, I've got my 0. The last thing I need to be in row echelon form is I need this -5 to be a +1. Okay? Whenever you're trying to get a +1, multiplication is your best bet. You can also use division. Division is just another way of multiplying. So really what I want to do here is I want to divide by -5. Technically we say that's multiplying by the fraction, -1/5. So I'm going to multiply everything in row 2 by -1/5, or I can say I'm dividing everything in row 2 by -5. And I'm going to keep the answer in row 2. So row 1's not changing. It's still 136. And I'm going through and I'm dividing everything by -5. So 0 divided by -5, still 0. -5 divided by -5, +1. And -20 divided by -5 is +4. What I've just done is I've finished step 2 because now I have my matrix in row echelon form. I can see I have those 1s on the main diagonal, the 0 below it, and then I don't really care what the other numbers are. So now I'm ready for step 3. Now I'm going to rewrite this as a system of linear equations. So the top equation, remember the first column was x, the second column was y. So the top equation is 1x plus 3y equals 6. Remember this bar is your equal sign. The bottom equation is 0x, don't need to write that, plus 1y equals 4. And what happens with Gaussian elimination is that your last equation is always a single number. So I have found out that y equals 4. So in step 4, I'm now going to use back substitution. That just means I'm going to back up a row, and I'm going to substitute the value. So I know that y is equal to 4. So I'm going to take the first equation, and I'm going to substitute y with the number 4. And this will be how I solve for x. So I'm multiplying 3 times 4, and then I'm going to subtract 12 from both sides. And I'm finding out that x equals -6. So the solution to this system, is x equals -6, y equals +4. This will be the end of our notes. Make sure you leave some space for your summary.